we are, as you can guess, we are going to continue with where we were last time. Kind of do a little overlap question. We're pretty much finished with straight lines. There are a few bits and pieces that we need to do. First question, kind of where we left off is, if you're given the equation of two lines, and I prefer this version, right? Are they parallel, are they skew, or do they intersect? Right, that's going to be our choices. So I'm going to take you through kind of the way that you would probably, I think, that you should probably approach this. So first thing I would do is find the direction vector of the two lines. Now, getting the direction vector that was used is quite easy. It's the coefficient of the variable. So in this case, it's 1t, -2t, and -1. So that ends up being 1, -2, -1. Are you happy how I can pull out the direction vector by just using the coefficient of t's? And for the second one, then, it would be 2, -4, -2. Now, if two vectors are going to be parallel, then their direction vectors should be parallel. That makes sense. Right. Now, you can do it by eyeballing it. Would you agree that this one's twice that one, or this one's half that, depending on your perspective? You agree? And if they're multiples, doesn't that make them parallel? So that would be parallel. Now, if you want to do it as a test, you divide corresponding components, and if the answer is the same, then they are parallel. So parallel's pretty quick, right? If they're parallel, you'll know it pretty much right away. Even if these are weird fractions like 3/7, won't you get it because the division is 3/7, 3/7, 3/7, right? It'll come out when you simplify. So what about these two then, which I'll set up in a few seconds. These two are not going to be parallel, but they could be skew or intersect, right? They're going to be one of those two. I'll keep the first one exactly the same, but I'll have a different vector for this one, a different line. So it's going to be 2 plus 2s. Just give me a second to figure out how I'm going to do this. It's -2. Okay, I hope that works. So we've got two straight lines, and we're checking, are they parallel, skew, or do they intersect? I know this is going to happen, but I'm going to test it anyway. The first thing you should always do is just check out to see if they're parallel. So this is 1, -2, -1, and this fella is 2, -2, 1. Just by looking at the components, would you agree that they are not multiples of each other? Can you tell just looking that they're not going to be multiples? But the test would be 1/2 that guy and that guy, in which case I get -1/2, 1, and -1. Do you see that these are different? Conclusion, they are not parallel. Now, if they're not parallel, you've got a lot more work to do than if they are parallel, right? If they're parallel, the question's over, right? If they're not parallel, we have to now decide between skewed and intersect. So the way that we do that is compare the components. So if you take the x, if they did intersect, then 1 plus t would have to equal 2 plus 2s. And if I subtract 2s from both sides and I subtract 1 from both sides, I get that equation. Let's check that out. Yeah, okay. Now if I compare this fella and make it equal this fella, I'm going to get quite an interesting kind of moving things around. I'm going to get negative 2t plus 2s, and it's going to equal negative 4. I'll call that equation 2. So when you match the x's, you got that. After a little bit of simplification, and you match the y's, you got that. What we're going to do is solve the system of equations. Okay, so I'll write them down next to each other. T take away 2s is going to equal 1, and negative 2t add 2s is going to get me negative 4. So when I add these equations together, because you know, we got kind of lucky here, we can just add them. And if I do that, they cancel out, and adding these gets me negative t, and adding these gets me negative 3. So I now know that t equals 3. And if I put t equals 3 into any equation I like, let's say that top one, I should be able to find out what the s value is. So by matching the x and y, I have found out that the only way that this is going to happen is that when t is 3 and when the s is 1. So I'm now going to return to the equation of each line. There's the first line. Again, this there. And here's my second line.
Professor?
Yes.
Sorry if this is a little bit late. I was just hung up on the second equation that you created. So you did 2 minus 2t for that one. How did you get the other side of that one? Or did I just copy it wrong?
Well, maybe I wrote it down wrong. You know, I'm capable of that. So are you talking about here?
Oh, yeah. So that came from the y part, right?
Right, yeah. So 2 take away 2t goes here, and negative 2 take away 2s goes here.
Mm-hmm.
And then what I did is I added 2s to both sides to get this, and I subtracted 2 from both sides to get that.
Sorry, I have my two equations stacked on top of each other, so I accidentally looked at the one from the previous problem. Okay, thank you so much.
Well, I'm really disappointed in you because I never, ever make a mistake. I mean, I can't remember the last time I did anything like that. So you're obviously in the wrong class. That's all I can say. Okay.
Understood, thank you.
Okay. You know I'm joshing. Okay. So taking this equation and plugging in 3, let's find out where that point is. So 1 plus 3, 1 plus t, 1 plus 3 is 4. Putting in t equals 3 here gets us what? 2 take away 6 is negative 4. 0. And plugging s equals 1 into here gets me 4. Plugging s equals 1 into here gets me negative 4. And plugging s equals 1 into here, I get 0. Do you notice that those two correspond to the same place? If I had plugged it in and these two are guaranteed to be equal, right? Because of the way I solved for it, right? These two are just going to be equal. But this was 0 and that was 10, right? Imagine that happened, right? If this was 0 and that was another number like 10, you would be looking at skewed. if this number is the same as that number, you are looking at the intersect. And not only do they intersect, I even know the coordinates of where they intersect. So if you do the match the X's and Y's system of equation, you're typically going to get a solution, right? You're going to get something that works. All that does is tells us what the first two are going to be. Once you plug it into here, if the Z components agree, you've got an intersect. And if the Z components have different numbers, can you just pretend that you know, I haven't used that guy yet, right? Can you pretend that said -1 plus a million S? Wouldn't that be a totally different Z value, right? And we're done. So if they match, intersect. If they don't match, it's good. Any questions about that? Are we good? Okay. The last thing I want to do then was straight lines. How to find where a straight line intersects a plane. If it does, because it might not. So imagine this is a plane in 3D space. And here's my line. Would you agree that if a line and a plane are going to interact, that they only intersect in one point? Would you agree a piece of paper and a line, like a bullet shooting a hole through it, won't it only hit it once? You might say, well, why is that the case? Well, to me, it makes sense. You imagine a flat piece of paper and the thing hits it, right? And it pops out the other side. Would you agree that the plane's going to continue and the line's never going to catch up with it? So in this case, it would intersect. Now, the reason I said if it does, there are technically two other situations. Couldn't the line fly above the plane? In other words, it never meets it, and it never meets it, because can't the line be parallel to the plane? Isn't that an alternate? So, can visualize it. Here is my plane, here is my line. Couldn't I just fly above it at the same height forever? If I bend my pen, won't it come in and intersect the plane, pass right through, but it will only do it in one location? So how do we solve that problem of how does a line intersect with the plane if it doesn't indeed intersect at all? So here is a line. And here is a plane. Anybody, any ideas how I could solve this problem? Equation of line, equation of plane.
Substitute x for x and y for y and z for z.
That's all you do. So make that x, make that y, and make that z. So it's going to be two lots of the x component of the line, take away 3 times the y component of the line, plus 2 times the z component, and it's going to equal 10. And so I get 2 plus 6t, take away 6t, plus 8, take away 2t equals 10. Kill. I have 10, take away 2. Oh, that's just a pure miracle of nice numbers. T equals 0 is a fluke. T equals 22, T equals 7, T equals 1,000,000, right? T will be 14/11, which is what it should have been because I just randomly picked numbers, but I guess I got lucky, right? Now, how does that interpret? simply find the position at 0. And it's 1 plus 3t, right? 1 plus 3 nothings, 2 nothings, and 4 take away nothing. And I'm worried because that doesn't make sense. Check my calculations. That is 2, that is 60, that is minus 60, that's good, that's 8, take away 2t, that is good, that's 10, that's nothing.
Shouldn't your z be 4?
Where?
Because it's 4 minus t in the r of t equation. So if t is 0, it would just be 4 on the bottom where you have the answer.
Oh, here? Oh, thank goodness. Now I'm happy because it works. Did you all catch that deliberate mistake? Right. It works. Now, can you imagine I did this for a different combination and I tried to solve the equation, right? Okay. And all the t's cancelled out, right? This plus t get killed by that and take away t. And I end up with this answer. What does that mean? I tried to find where the straight line intersects the plane. I did the substitution thing, but all the t's disappeared on me. And all I was left then was 0 and number 10.
Parallel?
What? It means they're parallel. And that means they'll never meet. And because they'll never meet, don't you get it's impossible, right? There is no solution. And that's how you do that. If you get a t value, any number including 0, I wish that wasn't 0 actually, plug it in, you'll get the coordinates. And that's called a position vector. A position vector is really just the coordinates, right? So it would be that point there. Do you want to see another one of a straight line meeting a plane? Or are we good with that?
Yes, I would like to see another one.
Okay, so this time I'm deliberately going to pick numbers that will be ugly. Here is my plane. Yeah, that should be ugly. And here is my straight line. 1 take away t, 3t, 2 take away t. Right, that's pretty random. Let's see what we get. 2 lots of x plus 5 lots of y. Add a z. And the whole thing should be 3. So 2 take away 2t plus 15t plus a 2 take away a t should be 3. 15 take away that, I believe that leaves me with 12t. That 2 and that 2 get me 4, take it away, and we get -1. Okay. The fact that that is a number means it is going to be a line intersecting the plane. You agree I've managed to solve it, right? What is the coordinates of that point going to be? It's going to be whatever that looks like on this line. So it's going to be 1 take away -1/12, comma, 3 lots of -1/12, comma, 2 take away -1/12. That's add, so that's 13/12. That's -1/4. And that's 2 add 1/4, so that's 25/12. And so the line intersects the plane, and it does it at the rather ugly coordinate that guy. Now, if you cannot solve the equation, because the variable t's disappear on you, you will treat that as a parallel situation, right? That the line never intersects. We cool? Right. Actually, although that's an ugly number, I'm happier that it's not 0. I think 0 was a distraction. Are we good now?
Yeah, I see that paper still.
Sure. There we go. So the next thing we're going to do is how to find the equation of a plane. A typical equation of the plane looks like that. It's a linear combination of x, y's, and z's equals a number. That's what planes look like. Okay, that's what planes look like. But how do we get the equation of a plane? Well, can you imagine this is just any old general plane? I need two things. I need to know a point on the line. Sorry, I should say a point on the plane. Let's call it P, and it's going to have coordinates x1, y1, z1. Let's make it that point there. There's P. That's the first thing you need. The second thing you need is you need a vector called the normal vector. And I'm going to call it A, B, and C again. And the normal vector is a vector that is at right angles to the plane. Any vector will do. Now, what do I mean by right angled? Can you imagine another line on the plane? There. I'm trying to, does that look more 3D-ish now that I've added that little dotted line to help us? So if I was wanting to find the equation of this plane here, this cardboard, my pen would be the normal. You see it's at right angles to my plane. And if you have those two pieces of information, the equation of the plane can be found by this slightly messy formula. It's ax plus by plus cz equals a naught x1, not a naught, a x1, b y1, and c z1. So the equation of a plane is ax by cz equals a times x1 plus b times y1 plus c times z1. It's a rather weird looking formula, would you agree? Let's prove it to you. Don't get an opportunity to prove things a lot. Let's pick a point Q on the plane. Any point at all, so I'll call it x, y, z. I know who P is. He's going to be called x1, y1, z1. So far, so good. Right. Any point on the plane, x, y, z. A point we know, x1, y1, z1. What do you know about the vector PQ and the normal vector? What do you know about those two? How do they interact?
Is the dot product 0?
Yeah, because aren't they at right angles to each other? Right. So the dot product is 0. Right? And PQ is second take away the first, second take away the first, second take away the first, dot product with A, B, C, and the whole thing is 0. And that times that gets me A x take away x1 plus b, y take away y1 plus c, z take away z1 equals 0. If you distribute it, you get this. And if you leave these three guys here, and you add that, that, and that to the other side, you're done. Actually, quite a pretty proof, isn't it? So that weird formula, this guy, all I need is a point on the plane, any one will do, and the normal vector. We've encountered this with straight lines. Aren't the equations of straight lines not unique? For the same straight line, there's lots of different formulas that do it. There's lots of different ways to write down the equation of the same plane. Right? Couldn't I choose a different point on the plane? And each time I choose a different point, I'd end up with a slightly different answer, wouldn't I? Yeah. We just live with that. There is a little bit of consistency, which is all equations of planes are multiples of each other. So if you write down any equation, any multiple, so if you double everybody, it's still the equation of the plane. Now, let's do one. Suppose I have a point 1, 2, -3, and I have a normal, and it's 1, 3, 2. Then this is my ABC. This is my x1, y1, z1. Then the equation of the plane is ax plus by plus cz equals ax1 plus by1 plus cz1. So it's going to be 1x plus 3y plus 2z equals 1 times 1 plus 3 times 2 plus -3 times 2. And we are done. So far, so good. So the kinds of questions that we're going to deal with are find equations of planes. And they're going to start off nice and easy, like this one. And then they're going to make it harder and harder to find the normal, and sometimes even to find P. So here is a different question. Find the equation of a plane that passes through the point 1, 0, -3 and is parallel to the plane 3x minus y plus 5z equals 10. Now I got my point, so I'm happy about that. I don't have my normal vector. If my plane is parallel to this plane, what is my normal vector going to be?
A multiple of that vector.
Or just that vector, right? Might as well just use the numbers that are there. So 3, -1, 5. Have you noticed that the coefficient of x, y, and z are the normal vector values, right? 3, -1, 5. Now you put this package together and you are going to get 3x take away y plus 5z equals 3 times 1 plus -1 times 0 plus 5 times -3. And that ends up being 3x take away y plus 5z. And 15, 3, I make that -12. Do you notice anything different between my plane and the one that it's parallel to? What's the only difference between them? This is the one we're parallel to, and this is my plane.
The 10 and the -12.
Yeah. So if you have planes that share the same X, Y's, and Z's, but have a different last number, aren't those planes guaranteed to be parallel to each other? Right? If you have the same normal, or if this one is like double that or treble that, the same thing is true. So how about this one? The point 1, -1, 1. And the plane is perpendicular or orthogonal. I think orthogonal is nicer, so I'll write that down. To those two planes. I got my point. What I don't have is my normal vector. How will I calculate my normal to this plane? It's perpendicular to that one, and it's perpendicular to that one.
You find the cross product of both normals?
Yes. Are you using the, if I don't know what to do, find a cross product rule? It's actually a good rule in these questions, right? So that's what you do. You take the cross product of that guy, right? 2, -1, 1, with this guy, 5, -3, 2. So I'll need a bit more room to do that. So move over here. My normal vector is going to be the cross product of those two guys I wrote down. This fella is 2, -1, 1. And this guy is 5, -3, 2. So it's so many i's, take away so many j's, plus so many k's. So I cover up this fella, and it's -2, take away -3, so that's -2 add 3, gets you 1. That's 4, take away 5, gets me -1. And that's -6, take away -5 is added, -6 got -1. And I'm kind of lucky today, and the numbers are quite pretty. Now, I have my point, which also happens to have a lot of ones in it, by sheer coincidence. And the equation of the plane then would be 1x plus 1y, take away z, equals 1 times 1 plus 1 times -1 plus 1 times, or -1 times 1, negative, 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 and I get x add y, take away z is -1. So if you are given a point and you're told that your plane is perpendicular to two others, you'll get the normal by a cross product of these two guys, right? The normals of these two guys. Are we cool? I mean, once I've shown you one, isn't every other one just the same question, but with different numbers, right? They don't change. So the ultimate version, the kind of last horrible version of this, is how do you find the equation of a line passing through 3 points? So, okay, imagine I've got a point P, a point Q, and a point R. If I join them up in 3D space, won't they form a triangle? But isn't that triangle a little baby plane? And if you expand it, you would get a plane. So if you want to find the equation of a plane, all you really need to know, isn't it, is 3 points on that plane. So this would be the plane that it would be part of, right? And that's the guy we're trying to find the equation of. Okay, so we need a strategy. I'm doing the first part because it's easy. I need a point on the plane. So I'm picking that one because I like P. Now the hard part. Don't I need to find a normal? That's what you're after. I need a normal. Can anyone tell me how they would go about getting that guy?
Do the cross product of PQ and PR.
You nailed it. What made you, I mean, you're right, exactly what you should do. What made you think that, what was going through your head for the, benefit of others?
There's 3 points, so I can make 2 different vectors with that, and I know that cross products give you orthogonal or perpendicular to the plane.
Yeah. And that's what n is, isn't it? Yeah, nailed it. In this case then, PQ, okay, be careful. Second take away first, 2. Second take away the first, -3. Second take away the first, -3. Cross product. Second take away the first, second take away the first, second take away the first. Hopefully I got that right. Okay, so this is PQ and this is PR. So I should be able to set this up. This guy is 2, -3, -3. This fella is 1, 3, -2. So it's going to be so many i's, take away so many j's, plus so many k's. Okay, that's 6. Take away -9 is 15. That is -4. Take away -3 is add 3, so it's -1. And this is 6. Take away -3, which I believe is 9. So my normal vector is 15, 1, and 9. Does that look okay, guys? I'm not saying I'm wrong, just in case I am. Are cross products becoming second nature now that you don't even worry about what you're doing because you've done so many of them? I hope you're at that point, right? Like you just go boom, 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 boom. Well, let's put it together then. What do I have? I have a point, 1, 2, 3. I have a normal vector, 15, 1, and 9. And so the equation of the plane is going to be 15x plus a y plus a 19z. And it's going to be 15 times 1 plus 1 times 2 plus 9 times 3. So it's going to be 15x plus a y plus a 19z. 15, 16, 17, and 27 is 44. And there's the equation of your plane.
Mr. Robertson,
Yeah.
where did the 19Z come from?
I have no idea. I scanned wrongly. It's only 9. Huh, there. It's 9. I don't know where it came. I probably scanned these two and wrote them down together. Thankfully, the calculation used 9, so it's only one minor change. Right, that's all I want to do on lines and planes. And you will find that there are some combinations that you have to think about that we haven't covered, and that's fine. But that'll give you a chance to kind of think it through yourself. So, oh, okay, a new chapter. Vector functions. Also called space curves. I like the name space curve. So how do you, in 3D, describe a curve? So, kind of hard to draw, but I'll do my best. I want you to imagine a curve in 3D space, right? So, tipping my finger is a curve. Can you see how in 3D space it can bend and wiggle in all sorts of different ways? How do we describe a space curve, right? A vector function in 3D space. And one of the things that a vector curve has that you don't get in 2D curves is that there is a direction, and that's called orientation. You either travel along the curve in the order that I've written it, or you travel against it, right? So space curves have a direction, right? So when I say y equals x cubed, there's no direction to that. I guess you could say traveling from left to right, but there's no real direction to it. We call that orientation. And the way that we describe these things is by a vector function, which is that guy. Hey, we've met him. Isn't that the same notation we use for straight lines in 3D space? Well, aren't 3D lines in 3D space, aren't they just examples of, you know, a curve in 3D space? It's just a straight curve. In general, they're written like this. So an example would be a straight line. Do you recognize what a straight line looks like in 3D space? Aren't all the terms linear, right? That's what we've just finished doing today, for instance. Right? But it can be anything. For instance, you could have a space curve that looked like this. So for any given value of t, can't you plug t in here, like t equals 0, t equals 0, t equals 0? And won't that give you what's called a position vector, which is essentially the coordinate, right? And couldn't you do it for t equals 0, t equals 1, t equals 2, t equals 3? And if you continued that, wouldn't you eventually draw a curve in 3D space called a space curve? I would like to draw a space curve. I would like to visualize it, because I'm hopeless at drawing in 3D. And we have some software that will allow us to do that. So just give me a few seconds just to load it up. While I'm doing that, why don't you do attendance? So put your last name down. And I am ready while you're doing that. There are two different bits of software. Let's do GeoBra first. Are you looking at GeoBra? Right. So I'll go up here. I'll do my little bracket. Fingers crossed it likes my little bracket. I'll do t squared, comma sine t, comma cosine t. And then I'll have a look and see, well, oh, come on, I'm hating. Bracket. Right, got it now. t squared. Oh, that's kind of cool. Sine t. Kind of nice. Cosine t. Yeah. Right. Can you see that curve is actually in 3D? I wasn't expecting that because it's just a random. Doesn't that look like somebody has just done a bent skateboard or surfboard? I have just by sheer fluke designed a new surfboard. You see my surfboard's curved. Aren't surfboards kind of flat? You didn't know this because I'm making this up, but that's a much more stable surfboard. And if you make one and you go in the sea, it's good, right? Nah, totally made up. But can you imagine shapes like that? Isn't it quite nice that you can describe boundaries of shapes? Now, if I go here and I do t, comma, sin t, comma, cosine t. Oh no, it's picking up brackets I don't want it to pick up. Sine t, comma, cosine t. There we go. Should be able to make this one go away. Right. Can you see a kind of sinusoidal curve here? But if you turn it, oh, you see it's not a sinusoidal curve in the usual sense. In fact, if you orientate it, it's a circle. If you orientate it, it's a sine curve. And if you orientate it, it's a different kind of sine curve. And if you look at it like that, slightly off, it's called a helix. That shape's called a helix. Kind of cool. So you want to play about with this guy? You do the bracket. First guy, comma, second guy, comma, last guy, finish the bracket and let this thing do its thing. I think it's kind of cool. So space curves are the 3D version of y equals x squared, right? 2D curve, right? Any questions so far? So we've got time. Oh, darn it. We're having so much fun. Tomorrow, we will get to do domains of space curves, which basically are usable values of t. Because you know some values you can't use. If I had the square root of t in one of these 3 spots, would you agree I could only use t if it was positive, right? I couldn't use it if t was -2. So we'll do about domain. We'll do limits of space curves. Right? What's the limit as t tends to infinity of a space curve, right? Things like that. Fortunately, we don't have any time today to do it. And I think there's some questions where you get to draw the thing, which means you get to do what I just did, and there'll be like 4 pictures and you pick the right one. But that is for another day. So you've hopefully already said your name and bye-bye, and I'll hang about for any questions. Otherwise, I'll see you tomorrow.
I have one.
Yes, David.
On our videos for our class, there's one that you put in the wrong place.
One what? Lesson?
In week 8, for Tuesday, you put in last Friday's video.
I think I've got a little note here, but obviously I didn't pay attention to it. Friday, not Tuesday, so I wonder if that's what it is. So let me take it in more detail. In math, 163. In week, which week is it?
Week 8.
Week 8. And what's wrong with week 8? The video?
Video is not the right one. It's last Friday's. instead.
Right, so the video that's not right is Tuesday's video is not right.
Mhm.
So video Tuesday, not right. Put in correct one. Now I know what I've meant to do. I'll get that done. Won't be able to do it right now, but if my office hour is quiet, I should be able to do it.
Uh-huh. I
Thank you.
just like sometimes going over the videos.
No, I'm glad you do that. I'll make sure that that one has actually got the right video in the right slot. Any other questions?
Nope. Have a good day.
Okay, we learned some cool stuff today, didn't we? Oh, we've still got other people. You got a question for us?
Yeah, I have a question for number 11 on the homework 12.4.
Okay, let me go hunting for that one. 11, 12.4. Leave that. Leave that. 12.4. Here we go. Okay, it must be the only question that you've had a trouble with because it looks like you got all the others correct.
Yeah, the only one I've had troubles with was number 8 and number 11.
Okay, so do you want me to do 8 first, or is 8 just something you haven't really spent time on yet?
You can do 8 first too, if you can.
Okay, let's do 8 first. In question 8, it says find the vector with not with determinants using the properties across products. Okay, so we're being asked to find k cross I minus 7j. Okay, and so I'm going to distribute that. That's k cross I, take away 7 k cross j. If you do these little triangle things, it helps me anyway. There's I, there's j, and there's k. Okay, if you want to do a k cross I, you're going to go k cross, where's k, where's I? Yeah, k cross I, you're going up the way, and so the answer is going to be positive j. So k cross I, if you follow the arrows, it's always the third letter. So k and I are going to get you some kind of j. If you get to it by following the arrows, it's positive. If you do it against the arrows, it's negative. So let's say k is here, going a j. Do you see I'm now going against the arrow? So what does that give me? It gives me an I, but a negative of it. So there's your answer. So if you take any I, j, and k, any two of them, the cross product is the third one. If you're going in the direction of the arrow, it's the positive third one. If you go against the direction of the arrow, right, see I'm going against the direction of the arrow, then it's a negative of them. Okay. That little triangle is just a convenient way of remembering them all.
Okay.
And the next one was what?
11.
11? 11?
Yes.
Okay. So in question 11, I have a picture that looks something like this. And this vector here has a magnitude of 2, and this vector v has a magnitude of 4. And we're being asked to find the magnitude of the cross product. Okay, what is the formula? It's the magnitude of u times the magnitude of v times the sine of the angle in between. So it's going to be 2 times 4 times the sine of 60 degrees. And the sine of 60 degrees is root 3 upon 2. So it's 8 times root 3 upon 2, and the answer is 4 root 3. I'm not quite sure why you got 0. Did you think?
I think I tried to do. What did I try to do? Let me look.
Well, whatever it is, don't do it again. That's a short thing.
I tried to do a cross product of I tried to do a cross product of 4 times cosine 60 and 4 times cosine sine 60. I don't know why I did that.
Well, if it's a single vector, those formulas are the x and y components of them. So it kind of makes sense if it was one vector, but this is 2 vectors and they're not in the x-axis anyway, right? They're orientated quite differently from that. And that's the guy that you use. In fact, they didn't tell you this, but that guy that you've just found, isn't he the area of that parallelogram?
Oh yeah.
And if you have that number, isn't it also the area of that triangle? So that's the parallelogram, and that would be the area of the triangle. So they could have asked you that instead. Right.